Hi guys, so let's do lesson 1.3, real numbers in the number line. This is the second part. So the objective that goes with this part, we're going to classify, graph, and compare real numbers. And this might be completely new to you guys, so there's a lot of vocabulary. You definitely want to make sure you write all this down. Alright, so the vocabulary first starts on page 17. The first thing we have is a set. And these three things aren't the important vocabulary, that kind of comes later, but a set is just a defined collection of objects. And like examples for math would be real numbers. Real numbers are a set, integers are a set, whole numbers are a set, fractions are a set. So that's just, a set is just a group of things that are the same. Elements of a set is just an object in a set. So I gave a couple examples. 3.4 is an element in the set of real numbers. -9 is an element in the set of integers. And there's a ton of examples. And then subset is just parts of a given set. And I'll show you what that means in the next slide. But here are the examples. And it kind of got cut off. I apologize. But it's not that important. So when you think about the real numbers, you can break the real numbers down into rational and irrational. So rational and irrational are both subsets of the real numbers. And then integers and rational numbers are both subsets of a bigger set of real numbers. So that's what we're going to get into, is just keep breaking down these sets into smaller subsets. And then more vocabulary. Now this is the important stuff. So the whole number system, like every number system, it's broken into two categories. There's real numbers, and then there's imaginary. I kind of run out of space. But all we worry about in algebra is real numbers. So the real numbers, there's two sets, rational and irrational. And you can copy down this if you want, but there's a really good chart I'm going to show you. So real numbers and then irrational numbers. Okay, so the real numbers, two sets, rational and irrational. So rational is any number that can be written as a fraction, a terminating decimal, or a repeating decimal. So all fractions, like 1/2, even mixed numbers, like 2 2 2/3, because you could change that to an improper fraction. 6, that would be 8/3. Terminating decimals like 2.5, and then repeating decimals like 3.44, and usually see the repeating bar over top of it. So those are rational numbers. Then this might be new, natural numbers. Those are just the numbers, the counting numbers. You start at 1 and it goes 1, 2, 3, 4, 5, 6, 7, 8, and on. Then whole numbers, the first whole number is 0, and then it's the same exact thing. So the only difference between the two sets, natural and whole numbers, is just natural numbers start at 1, whole numbers start at 0. You're probably pretty familiar with integers. So those are just numbers and its opposite. So -2, -1. So the integers are all the negative numbers, plus then the opposite. So 1, 2, 3, 4. And then we have irrational. So natural, whole numbers, and integers all fall under the rational. And then on the other side, we have irrational. Those are just decimals that do not repeat or terminate. Like I always say, think of crazy people. Crazy people you would call irrational. So numbers that are crazy decimals, like would fill your whole calculator screen, those are irrational numbers. And they're most often square roots, usually like square root of 7. If you put that in your calculator, let me put that in my calculator. Whoops. Alright, my calculator's not working here. Okay, the square root of 7 is equal to, and I'm not going to write all this out, but it's 2.6457513, and it goes on and on and on. So that's never going to repeat, and it's never going to terminate. Okay, so definitely make sure you write down all of that vocabulary there. Alright, the biggest thing is first you have to decide if it's rational or irrational. So square root of 10. Now, think about it. Any number that's not a perfect square is going to be an irrational because it's not going to be a whole number. So, square root of 10, that is equal to 3.16227766. And even though it's kind of repeating as you go on more digits, it doesn't. So, rational or irrational, that's going to be irrational. Square root of 36, that's equal to 6. So, that's rational. 3 over 4, that's a fraction. That's rational. And pi is the most common irrational number because that no one has ever found an approximation, or no one has ever found like the end of pi or anything that's repeating in pi. Now, a lot of people ask this. Sometimes you can use 22 over 7, and they say, well, that's a fraction, so why wouldn't it be a rational number? This is just an approximation. This isn't exactly what pi is equal to, so when they say that pi is an irrational number, it really is. The fraction's just an approximation. Okay, now, I know it's a little blurry here, but this is the same chart that's in your book. I just took a picture of it. I think this really helps you because what you're going to have to do is name all the categories that a number falls in. So, it's kind of divided into two parts here. Okay, so if I draw this line down, we have the rational number side and we have the irrational number side. So the rational number you can break down into 4 categories. The first category would be the natural numbers. Okay, so if something's a natural number, and here's the examples. Square root of 25, that's 5. 4 over 2, that's 2, and 7. So if it's a natural number, is it also a whole number? Yes. Is it also an integer? Yes. And is it also a rational number? Yes. So you can always work your way up this chart. Okay, now is 0 a natural number? No, the first whole number is 0, and then it goes 0, 1, 2, 3, 4. So, but is 0 also an integer? Yes. And is 0 also a rational number? So do you kind of see how you can work your way to the left, but you can't work your way to the right? Because to the right, it gets more specific. To the left, it gets more general. So when you move on to integers, we have -3. We have -10 over 5, which is just -2. And we have negative square root of 16, which means you take the square root of 16, which is 4, and it makes it -4. So all 3 of these negative numbers, could they move this way into the whole numbers? No, because whole numbers start at 0, but they can move this way. So all 3 of those things will also be a rational number. And then rational numbers, now the first rational number is -2 over 3. For some reason, people always think if it has a negative on it, it goes with integers. But it has to be a whole number integer to count as an integer. -2 over 3 is not an integer. It's a fraction, but it is a rational number. Here's a repeating decimal, 0.333. That's a rational number. But if you try and take it the other way, it's not an integer, it's not a whole number, it's not a natural number. And then square root of 0.25, that's going to be a rational number, but it's none of the other ones. Square root, yeah. Okay, and then on the other side, we have the irrational number that's everything else. Again, this number right here, just because it's negative, doesn't mean it's an integer. If you took the square root of 123, you would get a decimal that never repeats and never terminates. Okay, it would be negative, but that doesn't make it an integer. So think about this box, and so if I give you the number 6, think about the most specific category you can go in would be natural numbers. So if you have to list all of the subsets, you start at natural numbers, then you work your way to the left. So 6, the subsets that 6 is in would be natural numbers, whole numbers, integers, and rational numbers. If I give you the number -10, the most specific that can start in is integers. So that's in the subsets integers and rational numbers. if I give you square root of 20, which is an irrational number, it's only in one subset irrational number. So the more you can visualize this chart, just think it goes natural, whole numbers, integers, rational numbers. And that's how it works its way out. Okay, so problem 3, to which subsets of the real numbers does each number belong? So think about 15. Is it a natural number? Yes, because it's just the counting numbers. So it's a natural number. If it's a natural number, that also means it's a whole number. If it's a whole number, that also means it's an integer. And if it's an integer, that also means it's a rational number. Okay? If it's a natural number, it goes in all 4. Part B, negative 1.4583. Now, just because it's a negative doesn't mean it's an integer. So it's definitely not a natural number because it has decimals. It's not a whole number because it has decimals. It's not an integer because it has decimals. But is it a rational number? So now you have to decide, is this rational or irrational? The only subset it goes in is rational because the decimals terminate. It goes 0.4583 and it repeats. So it's just rational. Okay, and 57. Is 57 a natural number? Yeah, it's a counting number. So we have natural. If it's natural, it's also a whole number. If it's a whole number, it's an integer. Oh, I forgot an R up here. integer. And that means it's also a rational number. Hopefully that makes sense. We'll work more with that tomorrow, and then you'll get the hang of it. So got it, number 3, square root of 9. The easiest thing to do is take the square root of 9 and make it 3. And start with the most specific. Is it a natural number? Yeah. So it's natural, which means it's also whole, which means it's also an integer, which means it's also a rational number. 3 over 10. It's not a natural number, it's not a whole number, it's not an integer, but it is a rational number because it's a fraction. Negative 0.45. It's not a natural, it's not a whole number, it's not an integer because you have decimals. The only place where you can have decimals is either rational or irrational. So it is a rational number because it's a terminating decimal. And square root of 12. You should know that that's not a perfect square, so it's not going to be a whole number. But the square root of 12, I'm using my calculator on your phone, which you shouldn't use because they don't work as well. But square root of 12 is approximately 3.4641 ... So that makes it irrational. Okay? Alright, the next part of this is inequalities because we're going to move on from just classifying them. You actually have to be able to order them. Hopefully you know these symbols: less than, greater than, less than or equal to, and greater than or equal to. If you didn't know, this part, or equal to, that's why these have an extra line under them, because that really is the equal sign. They just only put one of the lines. So less than or equal to just has an extra line under it. So memorize those inequalities if you don't know them, and you need to be able to say what they are. I know we always say, like, well, 8's greater than 5. You make the alligator mouth or the Pac-Man mouth face the bigger number, but how you would read this would be 8 is greater than 5. Okay, so make sure you know that that symbol going that way is greater than. So problem 4 says comparing real numbers. So what inequality compares the numbers square root of 17 and 4 1/3? So what I always do is figure out what the square root of 17 is, approximately. So square root of 17 is 4.1231. And I try and go 4 decimal places because you never know how many you're going to need. 4 is usually good enough. And then 4 1/3. 1/3 is just 0.333 repeating. So I have 4.333. Now, which one is smaller? This one right here is going to be smaller. So here's what they don't want you to do. Say 4.1231 is less than 4.333, because these aren't the two numbers they were asking you to compare. They were asking you to compare 17 and 4 1/3. So make sure those are the numbers you compare. So we have square root of 17 and we have 4 1/3. So the square root of 17 is less than 4 1/3. Okay, got it number 4? Compare the square root of 129 and 11.52. So let's take the square root of 129. That is equal to 11.3578. And we're comparing that to 11.52. So if you just rewrite these two numbers, square root of 129, 11.52, which one would be smaller? 11.35 is smaller than 11.52, so we're going to say that the square root of 129 is less than 11.52. So anytime you have a fraction that you don't know the decimal equivalent to, or a square root, just take the square root, and we'll use calculators for this, and then just compare which one was bigger. But make sure you compare the original numbers, not the decimal forms. Okay, problem number 5. This is the same thing, but this they just want you to graph them and put them on a number line. So here we have square root of 4. We have 0.4. Well, actually, I'm going to do it like this. Okay, square root of 4. That's equal to 2. Then we have 0.4. Then we have negative 2/3. So 2/3 is 0.666. So we have negative 0.666 repeating. We have square root of 2. That is equal to 1.4142. And then we have negative 1.5. See how some of them required a little bit of math, like square root of 2, and then this one, negative 2/3. But I stacked them so that all these numbers that are in the ones place are all lined up, so you can really easily order them. So least to greatest. So we're definitely going to have the negative numbers first. So what is the smallest number that we have there? Remember, when you do negatives, the bigger the negative, the smaller it is. So the smallest number, so from least to greatest, the smallest is negative 1.5. And I usually cross them off after I use them so that I know I already used it. And then next would be the next negative. Now, this is what it is as a decimal, 0.666, but remember, you want to order the original number, so I'm going to put negative 2/3. Okay, and then we took care of that one. Then, smallest, between 2, 0.4, and 1.4, we would have 0.4. Next smallest would be 1.4142, but again, we want to put the square root of 2, the original number, and then the biggest is square root of 4. So got it number 5 is the same thing, but they want you to graph it on a number line, so we'll do that at the end. So let's do 3.5. Oops, I want to slide it over so I have some space. 3.5, negative 2.1, square root of 9, which is going to equal 3, negative 7/2, which is negative 3.5, square root of 5, which is 2.236. Okay, so let's do least to greatest. Let's just write them in order from least to greatest first. So the smallest is going to be this negative 3.5. So again, we have negative 7/2. And then, and this time I'm not going to cross them off completely because I want them to kind of help me make the number line. So I'm just going to circle them. Then we have negative 2.1. And then for the positive numbers, we have 2.236, 3, and 3.5. So 2.236 would be the next smallest, so that is square root of 5. And then 3, whoops, sorry, we don't want to put 3. We want to put square root of 9. And then 3.5. Okay, now if we were to make a number line here, the smallest negative we had was negative 3.5. So if I put 0 here, we need -1, -2, -3, -4. And then the biggest number we had was 3.5, so we got to go 1, 2, 3, 4. And I know it's not equally spaced, but it's close enough. So then we just put the numbers on there. So 3.5 would be right here. -2.1, so we go to -2, a little beyond that would be -2.1. Square root of 9, that's 3, so that would be right here. -3.5, so we go to -3 and halfway there, but remember, the number you actually want to write is -7/2, and then square root of 5 is about 2.2, so we won't go quite halfway, and that's where the square root of 5 is. Okay, so that's how you order them, put them on a number line, and that's pretty much there is to it.